Hello everyone, here are the answers to what you couldn't find at the back of the book. From page 286, these are the two evens and then the AP problems. So practice these problems again, see if you come up with these answers if you didn't get them correct the first time. I will have a separate solutions video posted for you to take a look at these either today or by the end of the day or maybe first thing tomorrow. All right, so just to kind of review what we were doing last week, now, if we're trying to find the area bounded between a curve and the x-axis, we could set up an equation or an expression rather that will equal the total area. So I want you guys go ahead, take a moment to make a sketch of this, and then write an expression, or technically an equation, for the total area that will compute that area bounded by the curve y equals f of x and the x-axis on the closed interval from a to b. So pause the video and give that a try. All right, and if you need more time, just pause the video again. So it's important to notice how many sections we have of area. That's going to tell us how many integrals we're going to need. So here we could say that the total area is equal to this expression. And again, there's a couple ways we could write this. First, we have the integral from a to c of whatever our function is. So we just say f of x dx. Now, technically, and we're going to see this soon enough, that if we try to find the area bounded between two curves, let's say one isn't the x-axis, we just take the upper curve minus the lower curve. So in this case, the lower curve is the line y equals 0. So we would just take this upper curve minus 0, which is just f of x. But if we look at any area below, y equals 0 is the upper curve, so we get 0 minus. So that's why it becomes like the opposite if we're trying to find that. So again, you could write minus as long as the area is below. This would be the integral from c to d of f of x dx. Or you could still add all of these, but any area below, just make sure you take the absolute value of it. This is a little bit less writing, less notation this way. Next, we'll have plus the integral from d to e of f of x dx. And then minus the integral from e to b of f of x dx. All right, so again, we described the difference. If I'm just evaluating the integral all the way from a to b, that will tell me the net area, where I have more area. So if my integral value is positive, that tells me I have more area above the x-axis as compared to below. Or if my integral value is negative, that tells us that we have more area shaded below the x-axis than above. And if it's 0, we have the same amount of area above as we do below. So we now have total area, and as I related this to distance traveled, we can use integrals now to help us calculate total distance traveled. But first, we're going to build up to the calculus version of this. So for example 1, if you travel 65 miles per hour from 2 p.m. to 6 p.m., what is the total distance you traveled? Now we're going to represent this several different ways. The first way is going to be the simplest, that we understand the distance formula is just distance is equal to rate times time, right? So the total distance traveled is just going to be our rate at 65 miles per hour, and we traveled for 4 hours, which is 260 miles. The second way is we could create a graph. And here we know velocity is constant. So in other words, we could say our function would just be That's 65, so we would just graph a horizontal line here at y equals 65. And we know that we're traveling from time t equals 2 to t equals 6. Then we will create the area here. So here we would say area is equal to the total distance traveled, which is 65 times 4, which is the 260 miles. But now a third way, since we can connect the graph to an integral, we will use that. So we can say the total distance traveled. Now notice based off of the graph, we only have one shaded region, so we only set up one integral. And it's the integral from 2 to 6 of 65, say dx. So if we were to take the antiderivative here, it's 65x from x equals 2 to x equals 6. And this becomes 65 times 6 minus 65 times 2, which we could multiply then subtract, or if we factored out a 65, there again is what we did at the very beginning. Distance is equal to rate times time. So this is 65 times 4, which is 260 miles. So just like finding total area, we could find the total distance traveled using integrals. However, if we have any area below, we end up subtracting that, just like as if an object were to change direction. So our next question, though, is what if the speed is not constant? Let's say we have a speed function, s of t is equal to 3t plus 2. We're going to find the total distance traveled from t equals 2 to t equals 6, two ways, graphically and using an integral. And then the second part, this is the part that you're supposed to read in the book ahead of time. What is the average speed? So first, let's go ahead with our graph. So we're just graphing the line y equals 3t, or 3x plus 2. All right, so I'm just going to count by twos here, because our numbers are going to get a little bit larger. So when t is 2, we're going to be at 8. And then when t is 6, we're going to be at 20. All right, now what we created here is a nice trapezoid. So again, the area, total area, will also equal the total distance traveled. And we know that this would become 1/2 times 4. So if a nice geometric formula can be used, why not use it? So 2 to 6, that's going to be our height of our trapezoid. Our first base measures 8 and our second measures 20. So we get 56 miles. Now if we set up an integral, this would be the total distance traveled is equal to the integral from 2 to 6 of 3t plus 2. Now since it's a t, we're going to say dt. Take the antiderivative. So first write out what that'll be. So we should get 3t squared over 2, or you could write this as 3/2 times t squared. Then we'll get plus a 2t as t goes from 2 to 6. So substituting in a 6, we're going to get 3 times 36 over 2, which just becomes 3 times 18. So that's 54 plus 12. And we'll subtract. We're going to get a 6. 3 times 2 squared over 2, and then plus 4. So we get 54 plus 12 minus 10, which gives us 56 miles this way. All right, now part 2, we're looking for the average speed. So if we're traveling 56 miles for 4 hours, we just divide 56 by 4, and we're averaging 14 miles per hour. Now this is going to lead to a concept, an idea called average value. So that's one way to do this, but using the integral to show how we can connect this to an integral, that would simply be, because we got the 56 by going from 2 to 6, taking the integral of 3t plus 2 dt, so that's giving us the 56, and then we ended up multiplying it, or really dividing, so we'll multiply by the reciprocal here, of the time, the difference in the time. And that's that 4. So here we could say, we'll call this the average value now. So the average value, which is also equal to the average speed, is equal to 1 over b minus a times the integral from a to b of f of x dx. So it's just a nice little formula where we just take our integral here and we multiply it by 1 over the difference between our limitations here from a to b. So let's try one more using the average value. And again, it's the average y value. Now imagine we just had 10 ordered pairs. We wanted to find the average y value. We would just take all the y values, add them up, and divide by the 10 values that are there. But if we have an infinite amount of y values, we have to use this formula. So this is number 26 off of page 275. We want to find the average y value, or the average value of y, on the closed interval from 0 to 3 and where it occurs. So where it occurs means what is x? All right, so we are going to say, here's our function, y equals negative x squared over 2. So we'll say the average value is going to equal 1 over b minus a, so 3 minus 0, times the integral from 0 to 3 of negative x squared over 2 dx. And we could also look at that as a negative 1/2 x squared. So we're going to get 1/3. The antiderivative here is going to become a negative 1/2 times x cubed over 3 as x goes from 0 to 3. And then we'll just evaluate. So we'll get a negative 1/2. This is 27 over 3, so times 9, minus, and then when we substitute a 0 in, that's just a 0. So we're ending up with a negative 9/6, which is negative 3/2. So our average y value is negative 3/2. Where does it occur? Well, we just go back up to our function. Y is equal to negative x squared over 2, but now y is going to be that negative 3/2. So we'll multiply both sides by a negative 2, so we'll get 3 is equal to x squared. So x would equal plus or minus radical 3, but we're only on the interval between 0 to 3, so it occurs when x is positive radical 3. All right, so a new idea here is where we could find the average value of y over a closed interval using integrals. All right, so please continue to work on Check and Correct Friday's assignment. Like I said, I will have a solution video posted for you to check as well. And then continue on page 275, the set of problems here. And then find the total distance traveled two ways, meaning graphically and using an integral, for s of t is equal to 12 minus 2t from t equals 2 to t equals 5. And then try AP page 170, number 4, another free response question. No graphing calculator here. You'll have a couple days to still continue on that. And then don't forget to prepare for your quiz tomorrow. 10 questions. You will not have a question for approximation. It's all going to be either find the area using an integral, find the integral using area, evaluate a definite integral. So just those topics there from sections 5.1 to 5.3.